Identify and sketch the surface 4x squared minus y squared plus 2z squared plus 4 equals 0. As soon as you look at this, you see three variables, and at least a couple of them have squared terms. We know that we're dealing with quadric surfaces. That's the three-dimensional counterparts of our conic sections. Now, how to figure out what we're dealing with exactly? Well, one way to first start out analyzing this is to notice that our x, y, and z terms are all squared. Right away, we know we either have hyperboloids or ellipsoids. Okay, so let's set this thing equal to 1. We get our constant to one side and divide through accordingly. So we would be subtracting off a 4 and then dividing through by a negative 4. And we'll have it in the form that we'll be able to learn something about it in order to sketch or generate this with a computer. And once we have it in this form, we will notice that our y-axis is the axis of symmetry. And that's because we have the odd-signed term being the y term. We'll also notice that this is a hyperboloid of two sheets, and that's because there are two negatives. If two of the terms had sign positive, then we would have a hyperboloid of one sheet. And, of course, there's also the degenerative case, the cone, the double cone. OK, so we have our axis of symmetry. Now let's look more closely. When z is equal to 0, what happens? Well, our z term falls out, and we have what looks like a hyperbola. So actually, we will have hyperbolas in the xy plane, right? That's where z equals 0. And if we let x equal 0, similarly, we'll find hyperbolas in the yz plane, where x equals 0. All right, let's look for one more set of traces by letting y equal k constant. You'll notice we didn't say y equals 0 here, and that's because if we let y equal 0, look at that first equation, the y term will drop out, or the y squared term will drop, and we'll be left with a negative added to a negative number, and we, of course, cannot equal 1, so no point will satisfy that equation. All right, so we let y equal k. There'll be some constants that this will work for. We divide through by k squared over 4 minus 1 in order to get 1 by itself on the right. And we're going to recognize that we have a conic here, and we actually have an ellipse this time. We have the signs of both terms the same. We have positives. OK, so let's see what the traces tell us about this figure. We can recap what we've seen so far in terms of traces. We have hyperbolas in the xy plane. We also have hyperbolas in the yz plane. And finally, we found that there are ellipses for certain y equals k. And you can actually see here which k this will work for. All k, all y, other than y in the interval where we do not have our curve, which seems to be from -2 to 2. So as long as the absolute value of y is greater than 2, this should work. And you can see that what we have here is a hyperboloid of two sheets. Its equation is 4x squared minus y squared plus 2z squared plus 4 equals 0. That's in standard form. And let's just shade that in so you can get a better look at it.